In this video, we are going to talk about inverse variation, and we are going to address two competencies: illustrate situations that involve inverse variation and solve problems involving inverse variation. This is the equation of inverse variation. It's y equals k over x. It is read as y varies inversely as x. So k here is the non-zero constant of variation, or this equation can be read as y is inversely proportional to x. To find k, we will just multiply x and y. Other inverse variation equations are: number 1, y varies inversely as the square of x. So it can be written as y equals k over x squared. Number 2, y varies inversely as the cube of x. So it can be written as y equals k over x cubed. Number 3, y varies inversely as the square root of x. It can be written as y equals k over square root of x. The most important point that we have to note here is that if we see the expression varies inversely, k will be the numerator of our fraction. The first thing that we need to learn here is how to find k. Example number 1. Y varies inversely as x and y equals 20 when x equals 4. What is the constant of variation? So this is our equation, y equals k over x. And to find k, we will just multiply x and y. So our x here is 4 and our y is 20. That means 4 times 20. And 4 times 20 is 80. So this is our answer. K equals 80. Example number 2. Y varies inversely as x and y equals 60 when x equals 0.5. What is the constant of variation? So again, this is our equation, y equals k over x. To find k, we will just multiply x and y. Our x here is 0.5 and our y is 60, so that means k equals 0.5 times 60, and 0.5 times 60 equals 30. So this is our answer. K equals 30. The next thing that we are going to learn here is to solve inverse variation problems. Example number 3. If y varies inversely as x and y equals 25 when x is 8, find y when x equals 40. So this is our equation, y equals k over x. To find k, we will just multiply x and y. So x here is 8 and our y is 25. So that means 8 times 25, which is equal to 200. Now going back to our original equation, we are going to substitute k with 200 and x with 40. That means y equals 200 over 40, and 200 divided by 40 is 5. So this is our answer, y equals 5. Example number 4. If y varies inversely as x and y equals 24 when x equals 5, find x when y equals 30. So this is our equation, y equals k over x. To find k, we just multiply x and y. So our x here is 5 and our y is 24. So that's 5 times 24. And 5 times 24 is 120. Now going back to our original equation, our k is 120 and our y is 30. So we substitute. So that's 30 equals 120 over x. To find x, we can actually switch 30 and x. So we have x equals 120 over 30. And 120 over 30 equals 4. So this is our answer. X equals 4. The next thing that we are going to learn here is to solve real-life inverse variation problems. Example number 5. The time required to finish painting a room varies inversely as the number of people doing the job. If it takes 5 hours for 9 people to finish the job, how long will it take to finish the same job if 6 more people are added? First, let t be the time required to do the job, and n be the number of people doing the job. So this is our equation. T equals k over n. So the time t required to finish painting a room varies inversely as the number of people n doing the job. So because it varies inversely, our k is on the numerator. Now to find k, we just multiply t and n. So that's 5 times 9, which is 45. Now going back to our original equation, we are going to substitute k with 45, and then we are going to find t when we add 6 more people. So meaning to say our n becomes 15. So that's t equals 45 over 15, and that's 3 hours. So it means that if 9 people do the job, they will finish the job in 5 hours. But if 15 people are doing the job, it only takes them 3 hours. We have an alternative solution here. So if t is the time required to do the job and n is the number of people doing the job, we can have this equation. T sub 1 times n sub 1 equals t sub 2 times n sub 2. So our t sub 1 is 5, our n sub 1 is 9, and our t sub 2, this is what we are going to find, and our n sub 2 is 15. So 5 times 9 is 45. To find t sub 2, we divide both sides by 15. So 45 divided by 15, that's 3 hours. Example number 6. The force required to lift an object varies inversely as the length of the lever. If the force of 2,500 pounds applied 4 feet from a pivot point would lift a car, then what force would be required at 10 feet to lift the same car? First, let F be the force applied 4 feet from a pivot point, and D be the distance from a pivot point where the force is applied. This is our equation. F equals K over T. And to find K, we just multiply F and T. So our F here is 2,500 and our D here is 4. So 4 times 2,500, that's 10,000. Now going back to our original equation, F equals K over D, we are going to substitute K with 10,000 and our T with 10 to find F. So that's F equals 10,000 divided by 10. And 10,000 divided by 10 is 1,000. So that means our answer is 1,000 pounds. We have an alternative solution. If F is the force applied 4 feet from a pivot point, and T is the distance from a pivot point where the force is applied, so we can have this equation. F sub 1 times D sub 1 equals F sub 2 times D sub 2. So our F sub 1 here is 2,500, our D sub 1 is 4, our f sub 2 is what we are going to find. Then our d sub 2 is 10. So 2,500 times 4 is 10,000. To find f sub 2, we divide both sides by 10. And 10,000 divided by 10 is 1,000. So meaning to say our f sub 2 is 1,000 pounds. Thanks for watching, guys. This is teacher Rejil. Keep safe.